In this video, we'll be learning how to make efficient HTTP client calls in ASP.NET Core. So this is how our front end is going to look. We are making use of Swagger to test out the APIs, and we are making use of Open Weather API to demonstrate this. In order to work with this code piece, what you need to do is, first of all, go ahead and create one account on openweathermap.org and you'll get your API key for free. You can use that to test out this code piece. Now, what exactly this is doing? Now, what it does is it makes an API call to this API path and it accepts a parameter called city. So here, if I click on try it out and provide a city name like Mumbai, click on execute, and here you can see the results are coming up. The temperature is shown over here in Celsius, and other attributes are also shown, like whether rain will be there or not, coordinations, latitude and longitude of that city, and some other parameters. So let's go ahead and see how we can create such an application and make efficient use of HTTP client whenever we are sending such request to external API providers. The first thing that you need to do is create a ASP.NET Core API application, and once you've done that, you'll be presented with a directory structure of this sort. Obviously, you won't be seeing models and services and controllers. All you will be seeing is program.cs file. Now you need to create these three folders separately: controllers, models, and services. Some people prefer creating it as a client. I call it as service. So in the program.cs file, that's the main file, and then the app settings.json. So remember, I told you when you will create your account on Open Weather API, you'll be provided with an API key. Using this key, you'll be able to make some request using Open Weather APIs. Okay. So once you have provided that in app settings.json, the next step is head over to program.cs. Now here I've added these lines: add MVC, add controllers, and then this builder.services.add HTTP client. Here I'm giving that client a name called Open Weather API, and then I'm providing the base address over here. Now this is considered as the best approach, initializing your HTTP client. And once you do that, you make use of a weather service. So this weather service is going to make use of the HTTP client that we are having over here. And every time when this API will be called, the HTTP client base address will always be provided to the weather service, and the additional parameters that are required to be passed to this API will be provided by the weather service itself. The other things that you see over here from line 15 onwards are the usual ones. So Swagger comes in by default when you create a core web API project, and here all I've done is added some additional functionalities like HTTPS redirection, static files, routing, authorization, map controllers. Finally, we're saying app.run. So once you have mentioned this in program.cs, the next thing that you need to do is head over to your HTTP client solution and create a folder called services. Now inside this services, we'll be creating a file. In my case, it's weatherservice.cs. Now let's see what exactly we are doing in this. So here you can see that we have an instance of HTTP client, read-only instance, and then we have this configuration. The configuration is basically used to read the app settings.json file, and HTTP client is basically the HTTP client over here that we have added. Now here in the constructor, we are passing the HTTP client factory and configuration. Using that, we are creating a new client. So using HTTP client factory, we are creating the client, and do note the name over here. We are providing Open Weather API, and this is the same name that we have mentioned while creating or registering the add HTTP client over here, Open Weather API. Once that's done, the configuration is passed to the configuration variable, and this is where the service is making an API call. And how it's reading it, the first line is retrieving the API key. It's accessing the configuration, then the section Open Weather API, and within that, the API key value pair. So this will retrieve the API key, and then we are creating the endpoint. Remember, I mentioned that the URL or the base address is obviously part of the HTTP client itself. So all you need to do is just pass the endpoint over here. You can see that we are passing weather. The query parameter is city. App ID is expecting an API key, which we are providing over here. And the unit we have mentioned as metric. Now, once that's done, it makes an asynchronous call, gets the response, and it returns in this format, weather response. So we have a model which deserializes the data as weather response. So here we have the weather response, the coordinate, the weather, base, main, visibility, wind, clouds, sys. So all these data points we have created as weather response, and then comes the controller. So here, how this method is being called, that is the question now. For example, in program.cs we have mentioned everything. We have registered our services and HTTP client. That's all good. We have also created the weather service, which will eventually call the API. But how we will be calling this API? So to do that, you need to create a controller. Now, under controllers folder, you can see I've created a file called weathercontroller.cs. Let's open up this one. The first thing that you'll notice over here is the route. So it says this is the API controller, and then we have the route. The route says that this particular method can be accessed using this route, API/weather. And what we are doing within that is we are creating a read-only instance of weather service. So here we have read-only weather service, and then the constructor initializes this weather service. And finally, the HTTP GET over here says that I need city as a parameter, and this is what we are passing. Get weather, parameter is city, and this line of code basically gets the data from the Open Weather API using the service that we have created, and finally it returns that data. So that is how the whole program is working. Now let's understand why this is efficient. So if I go back to the weather service, and as I mentioned that we are making use of HttpClient factory, which is used to create the instance of HTTP client. Now this is considered a best practice in ASP.NET Core for several reasons. First being the HTTP client management. The HttpClient client factory manages the lifecycle of HTTP client instances. It reuses existing clients when possible, reducing the overhead of creating new instances for every request. This reuse avoids resource leaks and potential socket exhaustion issues. The other benefit is configuration centralization. Now, the configuration of HTTP client, such as base URL that you can see over here is centralized in program.cs file. We can also go ahead and add headers, timeouts if required in this very place. This makes things easier to maintain and change, and we can configure different named clients for different services, each with its own settings. So it's just one API that we are calling externally right now, and that's Open Weather API. Let's say you have other APIs as well from third-party vendors. You can name them over here in this very file, and each one of them will have its own set of base settings that you can then utilize to call them. The other benefit of making use of HttpClient factory is optimized performance. It makes use of a pooled and managed HTTP client. This can improve the performance of the application by reducing the overhead of creating and disposing of HTTP client instances. Now, the other thing that we did was in the app settings.json, we have this configuration mentioned. So the Open Weather API key is stored in the app settings.json file. This approach separates configuration from code, making it easier to change these values without modifying the code. We could have further enhanced this by putting the URL over here as well. So if you see in program.cs, the URI that we have over here, this could also be made part of the app.settings.json file. Now, other than that, what we have done is we have made use of asynchronous programming. So here, you see weatherservice.cs, we know that it's a third-party API and it could take time to return the response. So here we have made use of asynchronous programming. Now, asynchronous programming is used throughout our example. These methods improve the responsiveness of the application because they allow other tasks to execute while waiting for the HTTP request to complete. This is especially important in web applications where responsiveness can greatly affect the user experience. And finally, when you see the weather controller.cs, we are also handling exceptions, and it generates this HTTP request exception. So handling such exceptions is essential for robustness, ensuring that your application can gracefully handle network or API related errors. In program.cs, if you see, we have proper dependency injection pattern. This follows the dependency injection pattern, making it easier to test and maintain your code. It also adheres to the solid principle of software design. Then we have the controller organization. The weather controller that we have is organized as an API controller, which is a recommended practice for building APIs in ASP.NET Core. It uses attribute routing, as we explored earlier, to define the API endpoints, making the code clean and self-documenting. Then we have the content deserialization in our weather service. So read from JSON async is coming from the HTTP JSON. So system.net.http is providing this method to deserialize the response content directly into a strongly typed weather response. This simplifies working with JSON responses and eliminates the need for manual parsing. You also noticed in program.cs that we are making use of add singleton when we are calling this weather service. So why we are doing that? Let's understand that as well. So when we register a service using add singleton, a single instance of weather service will be created and shared across the entire lifetime of our application. This means that the same weather service instance will be reused for every request made to your API, and thus impacts on performance as well. Using this add singleton can have performance benefits because it reduces the overhead of creating and disposing of weather service instances for each request. If your weather service instance is stateless and thread safe, that is, it doesn't store request specific data, then using a singleton can be efficient. And here we are doing that. This also provides thread safety because it's important to ensure that the weather service is thread safe when registered as a singleton because it will be accessed concurrently by multiple requests. If your service has any state that could be modified by one request and affects others, you must handle thread safety appropriately. So that was how to make use of HTTP client in your ASP.NET Core application. Do let me know how you are calling APIs using HTTP client in your ASP.NET Core applications.